Hello, and welcome to this video presentation. My name is Paul Brett. I'm a Senior Software Support Analyst supporting the Transformation Extender product from IBM. The topic for this video is Use the ITX functions CPACKAGE and CTEXT. Feel free to reach out to me on popular social media channels at Paul Brett Tech. Knowing when to use these powerful text property modification functions can be key to successfully validating non-ASCII content. CPACKAGE and CTEXT, which I shall look at today, have two arguments. You have the object or literal as the first argument, and then the second argument is the one that causes the most confusion. One might think of it as the encoding to assume that this object is. Where would you use such a function? Well, let's look at that first run function on the screen. You're calling a submap and you're using the ECHOIN to send in the package of an XML document. If the XML document is already encoded as UTF-8 and the object that you are reading it into is UTF-8, this run function will convert that data into native prior to sending it to the run function as a stream. Now on the Windows platform this might not be a serious issue if you're using standard ASCII characters only, no 2-byte characters. However, if there are 2-byte characters or more, or indeed if you're using it on the ZOS platform where the default encoding native will not be ASCII but will instead be ASCII, then you will need to use the second form of run function. Again, we're calling the submap, we're doing the ECHOIN, we're doing a CPACKAGE, and the second argument, native, is telling the run function that this data is already native. Don't do any conversion before you send the stream out. So it will be sent raw as is, and will arrive at the target child map unmolested. Starting this demonstration in the ITX 1012 Design Studio, let's open our temporary source map and let's bust a myth straight away. Let's discuss what CPACKAGE is not used for. If I were to drag my in1 object here, which is defined as a UTF-8 item, and then wrap that in1 reference in a CPACKAGE function, with the second argument there being Latin 1, this will not convert the input object to Latin 1. This is not what the CPACKAGE is for. This rule here would assume that the input object was Latin 1. I'm writing out to a UTF-8 item, so it would do a Latin 1 to UTF-8 conversion before writing out to the file that's set as the target for this card. So that's where not to use it. If you want to do conversions of that style, you want to look into the convert function instead, or alternatively just drag and drop from one card to another. If this is defined as UTF-8 and this is defined as Latin 1, dropping input to output would convert UTF-8 to Latin 1. That's the way to do conversions. So let's have a quick look at child map here. My input card is expecting UTF-8 XML document. It's reading the file input.xml and it's going to write out a UTF-8 object into output.txt part of the XML. Let's just check the XML document is there and in the correct format. It is, it's UTF-8. And if I build and run this map, output.txt is created and indeed contains test string. That's great, that's the child map running standalone. Let's go to the top level map here, test. We're reading in the same file, input.xml. It's read into an object that is defined as UTF-8. It's a UTF-8 blob. And here I'm using a run function. I'm calling child.mmc and I'm echoing in the input1 object. And this is going to do a UTF-8 to native conversion and send that stream across. Now because my UTF-8 data does not contain any multi-byte characters, then this will completely work on the Windows platform. Build, run. So the map has completed successfully and output.txt contains test string. Okay, so let's build these maps for the ZOS platform and see what a complete mess the ZOS platform makes of it when we don't use a CPACKAGE function. I'm going to use map build all for ZOS, and then I'm going to start my file transfer program. Going to connect to my ZOS box, and I'm going to change the transfer settings to binary. I'm going to upload the child.mvs map in binary, and I'm going to upload the input.xml file in binary. So remember, the child map is expecting UTF-8 data, and because I've copied it across in binary, it remains UTF data even on the ZOS platform. Let's log into the ZOS platform now and have a look at that data. If we have a quick look at the input.xml file, on the ZOS platform you will note that it looks like garbage. This is because it is UTF-8 data, and the ZOS platform natively only displays EBCDIC data correctly. If I run my child map, I go to my test.jcl file, make a quick couple of changes. I'm loading ITX 10.1.2. My top level map that I'm going to run is child MVS, and I'm overriding the input and output with input 01 and output 01. Input 01 is set to read input.xml, and output 01 is set to write to output.txt. Now bear in mind the card is set to write UTF-8 data. It will also not be possible to view the output on the ZOS platform, but we will review the output on Windows after we've run the map. So let's submit the job. Return code of 0008 means it was successful. And if I have a look on the ZOS platform at that file, it will be garbage on screen. But if I go to my transfer program and grab a copy of output.txt in binary mode, bring it back to my PC and then open it, it says test string. So we know that that child map is working perfectly. Let's go try the top level map that does the run function, and we're going to see that it makes a bit of a mess. I need to make a small change to that first. Instead of child.map.mmc, I have to put in run map01. Again, let's build this for ZOS. In my transfer program, I'm going to send test.mvs in binary to the ZOS platform. And in my JCL, I'm going to make a couple of changes. My top level map is now going to be test.mvs. Run map01 that is called is going to be reading child.mvs. My top level map is going to be reading again input 01, but I don't want to override the output. The output is currently set to sync, and I want to leave that as is. Somehow I've got to get the output from the child to write to my output data set. That means another quick change to the run function. So let's pop that in here. -of1 dd output 01. I believe that will do it. So once again, map build for specific platform ZOS. Transfer it across. I believe we are good to go. Submit the job. As you can see that the map has completed with a return code of 16. This means there was a problem. And if we in fact go to the audit log, which I'm writing out to a fixed data set, you can see here that one or more inputs was invalid. The run function converted the data to native. The child map received the data as EBCDIC. It was expecting UTF-8, so it's basically always going to fail. So let's fix this situation now by changing the run function with a C package around in1. I'm going to put the brackets in now, type in the name of the function, CPACKAGE, and my second argument is going to be native. Now in here I'm telling the engine, just assume this data is already native and send it as is. So it's UTF-8 now, there'll be no modification done to the data, it will be sent as a stream to child. Child will receive UTF-8 and in theory should work now. So from the map menu, build for ZOS, transfer the map, go to our JCL, submit the job now, return code 8, this seems to indicate things are looking good. And if we look at the content of output.txt, it looks like garbage on the ZOS system. That's fine. Let's go to the transfer program. What I'm going to do is I'm going to delete my local copy of output just to prove that it's gone. In binary, I'm going to get another copy of that file. Output, let's refresh. There it is, output.txt. Bring that over. And then open it, and as we can see we have test string. So in my top level map I used the CPACKAGE function. I sent it to the child map. The child map was expecting UTF-8, it got UTF-8, and my override told it to write it out to the DD name output01, which was a file dataset output.txt, and we got our data correctly. CTEXT works much the same way as CPACKAGE, except it doesn't bring across any initiator or terminator of the object you point to. So there we have it, the correct use of the CPACKAGE CTEXT functions to identify data as something that is perhaps not, but to avoid an automatic encoding when you don't want it. I want to thank you for taking the time to watch my video presentation today. If you found the content interesting and informative, hit that like button. Perhaps leave me a comment. Consider subscribing to my YouTube channel, as I release content such as this on a regular basis. Feel free to reach out to me on popular social media channels at Paul Brett Tech. Thank you.